So in this video, we're going to talk about transformation of graphs and how things transform. And what I'm going to do is I'm going to use Desmos to help explain this. What I have here is I have a parabola, just regular y equals x squared. And we're going to look at how this parabola is going to change as we do things to the equation. So the first one that we typically look at is what if we multiply by 2 out in front? And what is that? And so I'll click on that and highlight it. And what it did is it made a parabola that was just a little skinnier. And if you notice on the red parabola, our original one, okay, get rid of the blue for a second. The vertex is at 0, 0. The next point is over at 1, 1. That should make sense. 1 squared is 1. And then if we go over 2, it's up 4, because 2 squared is 4. So then if I click on the blue one, get rid of that red one for a second, our vertex is 0, 0, because 2 times 0 squared is 0. So then if we go over 1, it's up 2 instead of over 1, up 1 like the red one was. It's over 1 and then up 2 because 1 squared is 1 times 2. And then the next point would be over 2 up 8 because 2 squared is 4, 4 times 2 is 8. So it stretches it. It's called a vertical stretch. And we'll summarize here in a few minutes. So a number out in front, if I change this to a 0.2, it makes it wider. So what happens is if the number is bigger than 1, it's going to be a vertical stretch or skinnier. If it's less than 1, actually between 0 and 1, then it's going to make it wider. It's called a vertical compression, pushing the graph down. All right, so let's look at what if the graph or the equation, I'm doing minus 3 inside the equation. When I say inside, I mean like inside the squaring. So if I have x minus 3, you should kind of be predicting in your head what's going to happen here. And if you guessed moving to the right 3, very good. If you guess moving to the left 3, that's a sensical guess. But it's kind of the opposite of what you would assume. Usually minus is associated with the left, plus is associated with the right. The reason why it's right 3 is because we're really trying to figure out what's making this 0. And so if we put 3 into the equation, 3 minus 3 is 0, so that means over 3 is going to be where that equation is going to be sliding to the right. Okay, so let's, and then likewise, if I said this was plus 3, it would move it to the left 3. Okay, so we've got our, what's called a horizontal translation if it's inside the equation. So chances are you probably can guess what the next one's going to be. If it's plus 3, it's going to move it up 3. And so, and then if it's minus 3, as you probably would guess, it moves it down 3. So this is called the vertical translation. Okay, if it's negative, we do negative, it's going to be y equals negative x squared. That's going to flip it upside down. So this is called a reflection over the x-axis, reflection. And then if we put a 2 on the inside, it also makes it skinnier. And this is actually called a horizontal compression by 1/2. And we'll take a look at why this is horizontal, why it's not stretching it vertically like we saw the other skinnier one in just a moment. We'll use the square root function for that. This would be called a horizontal compression by 1/2. And then if we put like, 0.2 in here, it's going to make it wider. That'd be a horizontal stretch by a factor of 1 over 0.2, which is a horizontal stretch by a factor of 5. And you can kind of see that here at 5, 0. If I can get on top of it and get the idea here. So at 5, 0 is our first point. Instead of over 1, up 1, it's over 5, up 1. It's stretched it by a factor of 5 horizontally. And then the other one is y equals negative x squared. And if you notice, that's right on top of the original graph. So what the heck did that do? Well, it actually is a reflection over the y-axis, but since this one is symmetric, you can't really notice it. So what we're going to do is actually switch up this is called a parent function, is y equals x squared. we're going to use a different parent function and look at this transformation here that we just looked at. So instead of y equals x squared, let's look at the square root of x. The green graph is y equals square root of x. So one of the things that we talked about with parabola being the parent function is if we put a 2 on the outside, that's going to be a vertical stretch. It's pulling it up by a factor of 2. So instead of going over 1 in the x direction, up 1 in the y direction, we go over 1, up 2. Or like this point right here is 4, 2. Instead of going over 4, up 2, we're stretching it by a factor of 2. We're going to be over 4, up 4. If I can get right on there, yeah, over 4, up 4. So it's stretched in the uh, y direction, or vertical stretch by a factor of 2. So if I take this out of here and I change that to a 2 on the inside, notice how it's not stretched this much. It's not considered a vertical stretch this time. It's considered a horizontal compression. So now instead of going over 1, up 1, we're over 0.5, up 1. And instead of going over 4, up 2, we're over 2, up 2. If I could click on it correctly. So it's a little bit more obvious with the square root function. Now the other transformation we looked at was negative. And we said if it's negative on the outside, it's a flip over the x-axis or a flexion over the x-axis. And that's pretty obvious there. And if it's negative on the inside of the function, then it's pretty obvious that is a reflection over the y-axis. So this one, since it's not symmetric, you can kind of see what those are. So if let's kind of see if you can summarize all of what's happening here. I'm going to change this third one. So let's say it's going to be negative point, let's do negative 0.5. Negative 0.5 x minus 3 squared minus 6. So what's going to happen when I click on this? You should kind of be thinking in your head, what are all the transformations happening here? See if you got it down. So I'm going to click on it. Let's see what you guessed. There we go. So this one's way down here. Looks like the vertex is negative 3, negative 6. Did you guess that? That it would be back 3, down 6? And if you did, marvelous. And then it's upside down, and that's because of the negative on the outside. And then if you notice, it's a vertical compression by a factor of 0.5. So instead of over 1, down 1, like we might assume, it's going to be, I can't click on it there. Come on, there we go. It's over 1, down 0.5. So it's a vertical compression of 1/2. One other kind of interesting thing to note, if I put a 2 here, that changes the horizontal. It's not, no longer is it left 3, it's actually left 1.5. And the reason why is you got to make sure if you're doing these, that this number in here would be in parentheses. Um, if it's not, you'd have to factor that 2 out. And so now this 2 is creating a horizontal, what would that be? A horizontal compression by a factor of 1/2, and then it's still moved to the left 3 if we put that in parentheses. So let's kind of summarize what's happening here. If you want to take some notes on this, that would be wise. The negative on the outside is a reflection over the x-axis. So if you need to pause and write this down, probably be a good idea. The A, we said, is a vertical stretch if A is if it's bigger than 1. If it's a fraction or a decimal between 0 and 1, it's called a vertical compression. And this would be a vertical stretch of A. So if there's a 2 out there, it's a vertical stretch of 2. If it's a 0.5, it'd be a vertical compression of 0.5. I forgot to type that in here. If it's B out here, what's happening there, that would be called a horizontal compression by 1 over B. So it's always the reciprocal of this number. So if that B is a 2, it's going to be called a horizontal compression by 1/2 if B is bigger than 1. If B is, 1/3, it'd be a horizontal stretch by 3. You do the reciprocal, so 1 reciprocal of 1/3 is 3. and that's if it's between 0 and 1. And then if it's negative, we set as a reflection over the y-axis. This x plus h on the inside, that moves it left and right, moves it left if it's positive, right if it's negative. That's called a horizontal translation. And then lastly, that plus or minus on the outside, that's called a vertical translation, and that moves it up k units if it's positive or down if it's negative. So that's kind of the basics of transforming functions. I hope that helped out a little bit. There you go.